Hello, welcome to Share Science. Today we're starting a new series called Explained, where we look at popular videos and explain what's going on. This video comes from our friends over at Crazy Hydraulic Press. If you want to know more, we've added a card at the end so you can check it out directly. In today's video, we look at a hydraulic press and how it reacts to old armor versus modern armor. Old armor comes from the 1940s, and we can see how it reacts in the press here. The press doesn't seem to have a whole lot of trouble getting through the armor. That's because the armor that was made around this time was hot pressed, and it was made to be manufacturable. That means it has a high strength, and you can see that it still takes a lot of effort to get through. 450 tons. But the press doesn't have too hard a job getting through it. When we take a look, we can see that the press went right through it. This is because when hot-rolled steels like this are stressed, they're made to move fluidly. Next, they look at modern steel. Now this is AR500, and this is going to be a much harder steel. Let's see what happens to the press in this case. In this case, we see a much different response. The armor is not actually doing anything. It's the press that's failing. So this shows that only the hardest materials are going to be able to get through the AR500 modern armor. Next up, they try a very hard cone. Let's see what happens. It's not looking good. It looks like they made a little bit of a dent, but not enough to pierce the armor. Now next up, they're showing these steel balls, but we don't know what they're going to do with it. They're getting liquid nitrogen out and making them really cold. Now the reason you do something like this is because the properties of steel change dramatically when you make it cold. So even something that's really, really hard and strong like AR500 can be made to fail if you make it really cold. Let's see what happens when we take the steel ball at liquid nitrogen temperatures against the modern armor. Ooh, it looks like they've started a countdown, so something's going to happen in just about 5 seconds. At 350 tons, there's this huge explosion. You have to slow the video down 100 times to see what's going on. The armor itself actually splits into 4 pieces. Now this can be explained with a property of steel known as the brittle transition temperature. There's an inverse relationship between strength and hardness and brittleness. The harder we make something, the more brittle it'll be when it fails. If the temperature is high enough, then our material survives, but if we make it very, very cold, the material embrittles and it can fracture quite violently. In fact, this became an issue in World War II with a series of ships known as Liberty ships. They made the steel in these ships too hard and too strong, and when they went through the frigid waters of winter, they started cracking in half. In fact, there's only one ship left today that hasn't failed because of embrittlement. As they collect all the pieces from around their shop, you can see how the material failed. There was some ductile failure in the beginning, and then it broke off into multiple pieces and failed catastrophically. That's because this kind of armor is jammed with carbon, which sits in between the iron atoms of the steel to make it stronger. Unlike the old armor that failed gracefully, the carbon acts to prevent any deformation of the steel until under enough stress, it fails, and we saw sometimes quite violently. We hope you liked today's video and this new series called Explain, where we take popular videos and explain them. If there's a video that you'd like to have explained, add it into the comments and we can put it in the series. Thanks for watching.